I am a first-year PhD student at Aarhus University, Department of Public Health, and I am very honored to have been chosen to present my research here today. And today I would like to talk about the EAT-Lancet diet and adiposity in midlife. So this diet was proposed in 2019 by the EAT-Lancet Commission on Healthy Diets from Sustainable Food Systems. It's proposed as an environmentally friendly diet, and it's called the EAT-Lancet diet. And as you can see from this plate model, the diet has a large emphasis on vegetables and fruits and whole grains, as we see in any other healthful diet. But it also has a large emphasis on plant-sourced protein as opposed to animal-sourced proteins, which are those we consume the most of in the Western countries. And the environmental friendly part of the diet might largely be due to the plant-sourced focus as opposed to the animal-sourced protein. And during my master's thesis, I figured that I would look into the healthiness of this sustainable diet. So I did that by investigating the aim of association between adherence to the EAT-Lancet diet in midlife and development in weight and waist circumference after 5 years in a Danish cohort. And I did so by looking into the Diet, Cancer and Health cohort. It comprises 57,000 individuals who were 50 to 64 years old at inclusion in 93 to 97, and participants were recruited from Copenhagen or Aarhus County. At baseline, participants reported their dietary habits, the lifestyle, weight and waist circumference were measured by professionals, and then 5 years later at follow-up, participants self-reported their weight and waist circumference. So obviously those were the data I had available, but if I could, I would have made an RCT where I exposed participants to this diet to see what happened at follow-up, but due to a lack of time and money and 2 months into my PhD, lack of experience, I guess I would have to go with the data I had at hand and make it look like the RCT the best way possible. So this is the classic RCT as we know it. We would like to investigate an outcome due to X. So we have an exposure at baseline, an outcome at follow-up, and sometimes we also have an outcome at baseline. But since there is no association between the exposure at baseline and the outcome measure at baseline, we can talk about causality in this design. And in my research, I had the EAT-Lancet diet at baseline, then I had weight and waist circumference at follow-up, but I also had weight and waist circumference at baseline. And I had to make some assumptions about my data. So I assumed that the diet score I gave participants at baseline, the diet I measured there, was actually a good representation of participants' habitual diet. So that would mean a stable diet before entry to the study. And due to participants' age, I also assumed that they had reached some sort of steady state in their dietary pattern, and therefore diet would also be stable during the follow-up period. And an RCT like that would never get money because no changes in exposure. So basically, I could not expect that anything would happen at follow-up. I do, on the other hand, also know that people tend to gain weight over time. So maybe I needed to make a more clear estimate. Further, I also don't know how the diet at baseline was associated to the weight and waist circumference at baseline. But I do know that those two are probably related. You look because you eat in a certain way, and you also sometimes eat because you look a certain way. So to account for my two assumptions, and for this unknown association, I decided to make a more clear estimate. So instead of looking at development, I decided to look into what is the 5-year follow-up weight and waist circumference for those with the highest adherence to the EAT-Lancet diet compared to those with the lowest adherence. And with that estimate, I had several choices in my analysis. So the first choice was to mimic the RCT because that's a golden standard. So I did so by looking at the direct effect of diet at baseline and follow-up weight conditioning on the baseline weight and waist circumference. But I also decided that maybe I should look at the whole thing, everything I have available. So I looked into the total effect of the diet at baseline and the weight and waist circumference at follow-up when I mediated through weight and waist circumference measures at baseline. And I did so in the multivariable linear regression models, and these were my results. So in the top lines, you can see the blue one is the direct effect of EAT-Lancet diet at baseline on follow-up weight. And here I found for those with the highest adherence to the EAT-Lancet diet, there was not a lower follow-up weight compared to those with the lowest. But when I looked in the green line on the total effect without the baseline adjustment, where baseline weight was a mediator of the association, I did, however, find a significantly almost 1 kilo lower follow-up weight for those with the highest adherence compared to those with the lowest. And I saw the same trend when I looked into the waist circumference analysis, and the direct effect was, well, significantly lower for those with the highest adherence compared to the lowest adherence, but I am pretty sure that 3.8 millimeter lower waist circumference will not provide a lot of health benefits. But on the total effect, I found a 1.5 centimeter lower waist circumference for those with the highest compared to the lowest adherence. And that could potentially provide some health benefits. So people probably all gained weight, but those with the highest adherence were those who gained the least weight. So I have 2 points for you to take home today. The first one is that we should definitely think about how we define or make more clearly defined estimates to improve our study designs. And the second point is that the EAT-Lancet diet will probably not kill us, no matter the adjustment levels. So that was all I had to say. Thanks for listening, and now it is time for you guys to say something.